Hello and welcome all. This is Bhupendra Patil from Rapidminer. I'm joined by my colleague Jeff Kohanis. The topic for today's webinar is AI and ML saves the day for support engineers. Essentially, we want to show you technologies that Rapidminer brings to the table for improving the support services function. But before we go into the actual details of the use case and how we did it, I want to talk about a couple of real world solutions that we have put together. We worked with a major Caribbean airline company, and as you can imagine, in the airline industry, the support engineers have to deal with agents that are, buying bulk tickets. They're trying to work with travel agencies. There are online websites that act as ticket consolidators. Plus, there are individual passengers and companies that have relationship with the airline companies. So the tickets that come in belong to different categories and have a different kind of severity attached to it, right? With this particular airline company, they were almost getting 500 to 600 emails or phone calls a day. And the support team was pretty much overwhelmed with just trying to make sure that the ticket is routed to the right group of people. Maybe it should be going to the travel desk agents and not to the individual passenger desk and so on, right? So that itself was a time consuming process for them. With Rapidminer, what they're able to build was a text mining process that pretty much takes in any support tickets that comes in across all the channels. Then depending on what they see in the ticket itself, they will be the system was able to auto classify the ticket into whether, hey, this belongs to an individual passenger, or this belongs to a travel agency, or this is a fare problem or a refund problem, and so on. So there are multiple classes that we're putting the tickets under, and then we're routing the tickets into the appropriate groups bucket so they could take action on it. So the immediate benefit was we pretty much solved the whole routing issue, which was the bulk of the time as soon as the ticket was opened up. But then given those tickets were upfront routed to the right folks, they're able to take actions and then turn around, the results or whatever resolution was pretty immediately. Also, eventually, we're able to build sort of severity ranking system. So that way the hot issues that needed urgent attention were handled ahead of others, non-urgent issues and so on, right? But overall, if I had to quantify this based on what we shared, got from the customer, they're able to get about 90% time savings there, and then 20% efficiency gain in terms of number of tickets solved and the average time taken per ticket. But the bigger winner in this whole story was, this being a consumer-facing industry, they were seeing a lot of, bad information complaints over Twitter and other channels. That definitely dropped down significantly by almost about 50%. So this was a big PR win for them, where not only they solved efficiency challenges internally, but from the outside world perspective, they're able to gain confidence of their customers. In a similar support issue that we solved with another power and light firm, in this case the support is not just people sending in tickets and everything is resolved over phone and emails, right? A power and light firm has actually people running around the towns and cities and whatnot, fixing power lines or meters and so on, right? So their support issue is not just related to how fast you can resolve, but also appropriately sending the right folks at the right level. So with Rapidminer, we're able to build again a solution here which was able to take in this support related data, analyze it, provide the region, urgency, what kind of issue it is, and so on, and then able to disperse the right people, right personnel to the right site at the right time. At the core of this, obviously, there's text mining, but in this case, there was also audio information. So we worked with the third party who converts audio to text, and then we're able to leverage that data. Now, essentially, this led to a service complaint reduction by 8%. And if you're a multi-million-dollar company, this numbers really make a huge impact on the bottom line. Also, the other part of this whole journey was since they're able to proactively classify tickets into appropriate groups, they're able to identify trends happening, and eventually we saw some actual information flowing where they're able to proactively identify, hey, we might have a major problem issue in this zip code or this territory and so on, and they're able to assign more personnel to handle it. So the solution actually was designed for helping the support team, but also helped in organizing the personnel for actually the services part of the industry. Now, these are two use cases that I chose to show here. As a company, Rapidminer has implemented dozens of these. In the text mining space, we have implemented hundreds of different use cases or different customers. But at the core of it, essentially, if you don't talk about the support function, you guys are dealing with thousands of monthly support tickets. A lot of times, severity information is not accurate. Everybody wants to think their problem is unique and the most important thing in the world. And so you'll typically see severity being tagged at very high in most of the support tickets. Customers choose not to use the right product classification, or they don't worry about it. You as a company are probably selling hundreds of services and customers, so that classification information is important. But generally, customers who are opening the support tickets may not be sending accurate information. And then a lot of these tickets are manually reviewed, which is just a time-consuming process. You don't necessarily need to have to look at every ticket to identify who should be looking at it for the solution. And lastly, with global teams that we work with, one of the other challenges that we have seen is, knowledge becomes, very dispersed around the globe. There might be 5 tickets, exactly the same tickets, but since they happened in 5 different territories, 5 different support engineers touched and resolved it, and there was no way to know that, the solution is the same. But with a machine learning model behind the scenes, it can act as the brain behind your teams. It can consolidate the information that has been generated across the globe and actually help the team across. And lastly, since we are doing all of this in real time, we can actually identify trends as they're happening. So eventually, the goal here is, bringing in a AI ML driven support team essentially helps your team to scale up. It should help your resolution times. It should help to make your customers happy. And then as a leadership, you'll be able to see and identify trends that are happening in the support systems, thereby telling you where the focus area should be for engineering or product issues and so on. So with that in mind, let's switch over to a demo where we'll showcase some of these capabilities, and then we'll talk about how we actually did it in a bit after that. So with that, I'll turn over to my colleague here, Jeff Kowanis, who's a senior data scientist at Rapidminer.
Hey, good afternoon or morning. So I'm Jeff, like BP mentioned, I'm a senior data scientist here. And so what I've done is I've built an example of this type of use case in Rapidminer, going from data to deployment. And what you should have for viewing right now is the dashboard. I have actually feeding all of the information from models that are scoring support tickets in the dashboard. So ultimately, what I have here is I have a way to call a given support ticket. I deliver that support ticket's ID to a web service. That web service calls a set of models built in Rapidminer where Rapidminer will predict what type of platform that ticket belongs in, and then ultimately has a topic model that defines the ticket classification. So what problem is the client actually dealing with? I track other stuff like submission date, the ticket body, and there are some other features that I'm generating, like a list of keywords and their importance to the prediction. So this platform prediction is defined by the keywords extracted here, and I'm just listing them by importance. So I can see tablet, check, app, Android obviously makes sense in the reference of this ticket to this Android prediction and the ticket classification for applications. Over on the right-hand side, I've got the most recent data. So in this case, I've got just the last 20 or so calls I've made to this web service. And then ultimately down below, I have a volume where I can select what my platform application was. In this case, I'm going with Android, where I'm tracking the tickets by class that have been submitted over the last 90 days. So I can see there's been a lot of tickets implemented about troubleshooting updates and then some other application issues that users have been dealing with. So this is a good way to track these metrics over time. The reason why I'm starting here is because this is where all great data science projects end up. And so this example is just a dashboard tool on Rapidminer called Grafana. So Rapidminer's hub has a dashboarding tool embedded in it. So I'm leveraging this here to show that output. But in reality, in the real world, this type of information might be the information being dumped into Jira or Zendesk or whatever tool it is that you're leveraging to handle your support tickets. So at the end of the day, Rapidminer is going to apply models as a web service and deliver this information and put it where you need to leverage it. And so this dashboard is just a good example of that process and that deployment process in action on Rapidminer. So for example, I have this as a little bit of an actionable dashboard. So I can take a random ticket, for example, like 408997 maybe. And I can input that ticket, and what Rapidminer is going to do is it's going to fetch that ticket from a database for me, apply my platform prediction, apply my my topic prediction, so I can see, oh, this one pertains to databases. In particular, they're having issues with SQL Server. So I get the ticket body, and I can see what my importances will update, and then I can come down here and say, okay, well, let's look at what other database issues have been spiking over the last 90 days. I can see, oh, well, there's been a lot of interest in SQL Server and just help formatting queries. So that's an easy one. And then I can easily cycle through other examples. But the idea here is that Rapidminer is taking the information I'm sending into this text box, using it to make a query, and then scoring that data that I've delivered with my model. So you'll see everything update here, and I can keep track of tickets. So this is an example of calling these models in real time. The other option is to do batch scoring or micro batch scoring, where as these tickets get submitted, I can score them and then dump the predictions right into Jira, Zendesk, etc. But this is just one example of a deployment in Rapidminer. Now what I want to do is I want to take you under the hood. I want to show you how a solution like this goes from connecting to raw data to text mined results to models built to models deployed. I want to show you what that looks like under the hub, because ultimately what's happening here is I've built a Rapidminer process in Rapidminer Studio and published that process via the AI Hub as a REST API. And that REST API is what's feeding all of the information coming into this dashboard. We can have that same REST API can dump into those other programs as well, or just write back the data into a database, which can be accessed by other programs. But in this case, I've got a web service feeding this dashboard. Now I want to take you under the hood and show you how all of that gets designed. So now on the Rapidminer Studio side, this is going to be the process designer, where I'm going to use a drag and drop process designer to build out a data science project. I'm going to go from loading in data to doing my text mining to building out models to ultimately deploying those models via a web service. And I designed this all in Studio. Now there are a couple of other tools in our repertoire here, like TurboPrep and AutoModel, which are more guided solutions. In this case, I went with the custom approach because I knew what I needed to build. So that's going to leverage this design view here. And so what I'm going to do is I'm just going to take us to process one here. Which is where I start this journey. I did a little bit of pre-processing. I'm going to save you the data loading steps, but ultimately this data comes from Stack Exchange. So I just took their kind of repository of posts and used them to generate my support ticket data. And so in this case, my project always starts out by retrieving some data. So I have the data stored locally in here in Rapidminer, but I can easily change around this area to be a database call, a SQL query to an Oracle database, for example. It could be pulling from flat files or even cloud repositories or something like Salesforce. Depending on where that ticket and the information is sitting, generally I build a connection and just connect to the data directly to the process. So in this case, I'm just retrieving my data locally because I'm storing this example. So this first portion of my process is just loading some data. So when I run this, it's going to connect to my local data set quickly here. And then it's going to dump out these results. So I've sampled this data set. So I've got about 1,100 records here. And basically what I did is I went to different sections for Stack Exchange and pulled them. So I pulled from 3D printing. If I go into my statistics, you can see my ticket types over here. I've got 3D printing, Unix, Apple, databases, Android, and basically said, okay, well, this is a high level version of my target variable. And I want to predict this main ticket type, right? I need to build a model, and the only information I really have is my post title, my full text, and my creation date. I can't really do a whole bunch of predicting with the creation date, but this is just a good field to have around. But ultimately what I want to do is structure this post coming from, or the full text coming from the posts, and then use that to predict this ticketing type. That's that first layer model where I'm just saying, okay, well, here's where this ticket belongs, and that's that platform prediction. So the process that generates that starts here. And the next step is to use my process documents from data operator to structure my text data. So in this case, the process documents does 90% of the work for me. It's responsible for generating my structured data. In my parameters, there's a vector creation. So basically, this is how I count my words. So I'm using a term frequency, an individual document frequency, and that ratio will be used as the data I'm going to train my model with. It also gives me the option to prune items too, so I can make it so if a word doesn't show up enough, I leave it out, or if it shows up too much, I can take it out. But this is also a sub-process operator, so inside of here is another design window. And this is where I actually tell the text mining how to define a word. And so essentially I do stuff like tokenize. In this case, I'm just doing non-letters because the posts are fairly clean in terms of character structure, turning everything into lowercase characters. I'm filtering a given stop words list. I've built my own stop words dictionary to handle URLs to take those right out of the text. Filtering tokens less than 3 characters, and generating n-grams. So terms that show up frequently together, I want to group them together. There are a plethora of other operators here you can use to cut up the documents and tokenize text, but these were the ones that I leveraged for this use case. And so there's a lot of iteration that happens. I always refer to text mining use cases as a very human in the loop interaction. And so this is where a lot of my work was spent, making sure I was getting the right text mined results. Now, once I have that, I take that structured data and I push it into this process here, where I'm going to generate a model. So I retrieve structured data from the text mining process. And then in the middle here is where all the magic happens. I have a cross-validation operator that's generating training data sets and testing data sets for me. And then I'm training a gradient boosted tree to make this ticket type prediction for me. So it's going to tell me Unix, database, Apple, Android, or 3D printing. So that way I know the general place this ticket needs to go before it gets classified into what specifically we're working on. And then inside of this, you can see I've broken up the cross-validation breaks up my process into a training and testing side. So everything I'm going to do with them to train a model is going to happen over here. So here I've got my gradient boosted tree, and I can include other stuff like principal component analysis, normalization, or feature selection. On the testing side, I'm just simply applying the model and generating a performance score. So in this case, I'm tracking stuff like accuracy, precision, recall. This performance vector for me is going to deliver a confusion matrix. And I can open that performance vector up so I can take a look at that model. So for example, here in my results, the performance for that model is fairly good. About 86% of the time, I'm putting it into its right topic. That's really good given I've got a 5-class multi-level classification problem. You know, I would love for every model that I build to have numbers like this. And so my class recalls are good. My precisions are looking good. I probably could, focus on improving this Unix score, maybe go back and work on the text mining a little bit more, or try out some optimization or feature selection. But the idea here is I've got a model and it's got a relatively great accuracy. If I'm hitting 86 to 90% of my tickets are ending up in the right bucket, that's going to save me a lot of work down the road. Now, the last piece of this is once I've made that prediction, what I also need to do is I need to generate some topics. So if I jump back to my dashboard quickly, the other layer of this use case is that once I've made this platform prediction, I'm also dealing with a subcategory. I need to know exactly what this ticket is talking about, not just the platform it's working with, but what subsystem or what important piece. So here I've got one that's classified for Apple. You can clearly see there's some stuff about installations, HDD hard drives for the device. So this might be a hardware installation, but it's close. It shares a lot of common words, which is good. I got hard disk rebooting, disk utility, partition. That just screams installation. So that's looking good. But in order to get this classification, I needed to build some topic models. And in order to do that, I leveraged an NLP operator, the LDA topic modeler in the Rapidminer operator toolbox extension. So this process looks a little bit different here. Once I open this one up, it's going to retrieve those same set of raw tickets, just going to downsample for me. So I'm using the same sample set. And the middle portion here is really important. This is going to prep my raw text. In particular, I pre-process some text by applying those same text mining steps to my documents that I did in the text mining step, just so I can remove a lot of the words or group words together. So that way the LDA can take the raw text that's been pre-processed by me and generate better keywords list for those topics. The last piece is I group this by ticket type. I basically say, hey, let's look at just 3D printing, and then let's build topics for that. So this is an example of unsupervised learning. So I've built a supervised learning model, and now I want to do a little bit of unsupervised learning. So in this last loop here, I've got an LDA topic modeler, which will take a number of topics. In this case, I just defined 10 topics, and it'll build those topics and list out the top 10 keywords for that topic. And so ultimately, I'm storing that model and that performance, and I can look at those items in Rapidminer as well. So this generates my topic model, which is giving me that topic classification on my dashboard. So this is kind of under the hood how everything gets built in Rapidminer. And now I want to put it all together. So all of these processes I'm running on Rapidminer AI Hub to generate these models. Now when I want to put this all into production, I've actually published a process I've built here in Studio as a REST API on Rapidminer's AI Hub. And that's what this process here is, what is feeding that dashboard all the information it needs. So for example, on my dashboard, I'm delivering an ID, and that ID gets sent to this process, and my database query uses that ID to grab the specific ticket we're looking for from the database. Does a little pre-processing here just to denote some important columns, and then it sends that information. It sends that ticket into this sub-process operator. This select sub-process operator has a bunch of sub-process windows in it, with each sub-process window being a vital portion of this process. So at the end of the day, it's going to deliver my model. This one's going to deliver my explain predictions table, and I have a couple of other sub processes in here that are each responsible for a box on my dashboard. So for example, that second sub process was delivering this keywords list from my explain predictions. The first one was actually applying the model, delivering this platform prediction. Process 4 delivers my group classification, and then the last one delivers my time series down here below. So the idea here is I've built a robust process that can deliver all of the information I need, and all I need to do is give it one piece of information, and that's my ticket ID. This is a good look under the hood of what drives these types of use cases in Rapidminer, both in Rapidminer Studio, the AI Hub, and deploying it out to either visualization programs or pushing out all of the results that I'm generating from these models to stuff like Zendesk and Jira, depending on what tools you're using for your tickets. So I want to thank you for enjoying the demonstration, and I want to pass it over to BP for his other remarks.
Thank you, Jeff. I'm going to quickly summarize a few things here and then point you to the resources that will be available. So let's start with sharing my screen again. So you saw Jeff walking you through the process behind the scenes and how it's deployed in a dashboard. Obviously, it can be deployed in any tool that you're currently using in your support systems. But to kind of tie things back together, the way RapidMiner works with organization like yours is we want to set up a COE with you, Center of Excellence, if you will. The idea is we want to understand, what your current processes look like in terms of, how you're handling your support tickets, and then identify what can be used for machine learning, the previous, ticket history, and so on. The goal here is to build and deploy solutions, and so that we can have an initial set of, solution built very quickly. We want it to be actually integrated with your systems, and then obviously iterate over it to continuously build and improve on top of the initial wins. And not every use case needs to be solved on day one, right? One of the things we want to teach our customers is just because you're looking to bring in AI and ML doesn't have to be that everything has to be done on day one, right? We could start off easily with a simple classification. Hey, let's classify the tickets into simple versus complex. You can divide it between the teams that handle the senior level and level 2 and level 3 and so on, right? We can then evolve it into multi-classification system. Building something like trend analysis is pretty easy. And then as we have more data and we learn more from the data, we can add other things like identifying topics in the tickets, or even bringing in recommendations, right? And the way we want to do this is organize it based on the value of feasibility. Is it even possible? And what kind of value it brings to the system, right? Maybe recommendations are not going to be useful, though, because your use cases volumes are low. So you can pretty much handle if it's routed to the right group. But in some cases where there are a lot of tickets and there's a lot of similar issues going on, maybe recommendations can solve you a lot of time. So those are the questions we want to answer with your team together and help you understand what to be built when. And pretty much the process after that is straightforward, right? We want to identify the data sources, how much training data we should be using, maybe 2 months worth of ticket or 2 years worth of ticket, depending on the life cycle of your products. Training model is iterative exercise, so we'll work with your team on that. And once model are built, we want to deploy them as either mini batch or some sort of web services. And then obviously, as the products evolve, the support tickets are going to change. The type of tickets you're going to see are different. So you're going to set up a cadence for retraining the models and how often and what data to be used and so on, right? Now, how does this look in real world? So with most of our customers where we have implemented a solution like this, in a matter of 1 to 2 weeks, we're actually able to deploy the first production solution, which is, we are able to work with your support software, whether that's Salesforce, Zendesk, Jira, or anything else. We can connect to that. We can build those classification models using the drag and drop approach that Jeff just showed you, and then really deploy it for either batch or real-time scoring. Now, the typical early goal is to be at least able to classify it into the product category. So being able to give you a high level like, hey, this ticket belongs to which product group, if you will, right? Once we are successful with this, the next part of this is kind of diving deeper, taking it past the topic level and actually telling you, the individual subset of issues, right? So within Unix, you could be having tickets of these 4 different categories or 5 different categories. Now, the good news is you don't need to tell AI ML platforms that this is what you're looking for. We have algorithms that will be able to identify what kind of different topics appear in the tickets and automatically assign them. So essentially, we should be able to take you from this step to the next step pretty easily without having to do a lot of manual labor. Now, at a high level, whether you're doing level 1 or level 2 or phase 1 or phase 2, as you want to call it, the solutions are pretty straightforward, right? There's always data prep required. If one of the questions that's on your mind is, do we have to have a predetermined groups or ticket categories and so on? If that is available, that is always good. But otherwise, Rapidminer has unsupervised techniques like clustering techniques or the LDA model that Jeff was referring to. They can be used to give you a jump start. So the data preparation part can be easily handled with Rapidminer. When it comes to modeling, we have an auto model tool which we did not talk about today, but again, that can be used to identifying which set of models fit your data well. If not, you could use the process designer that we just showed you in the demonstration. Or if needed, if you're specifically looking at some Python libraries that you want to incorporate and productionalize, we can actually use those also in Rapidminer. And then lastly, when you're ready to deploy, scoring things in a micro batch approach or a web service approach is a matter of few clicks in Rapidminer. And the same goes for monitoring and retraining the models, right? We have model management built in the platform that is going to look into this, tickets as they are being scored. It will identify any data deviations. It will identify any, model performance issues, and then can re-trigger a retraining of the models if necessary. So with that, essentially, we are able to go live from not anything in AI using AI and ML to a fully productionalized AI ML system that helps the support engineers in a matter of 4 weeks or 4 to 6 weeks. A lot of our customers choose to go further. Recommendation of ticket resolution is one that we talked about. This is also pretty straightforward with Rapidminer. We have algorithms that can look at document similarity and use that. If you need to add something like this, we look typically at a week or two of additional work. Uh, Trend analysis that we showed you in chart, that is great, but obviously nobody has the time to sit down and watch the charts. So we could set up alerts on those, like, hey, if X number of tickets reach for a particular topic, alert this team. Or if you're seeing a growing trend or a decreasing trend, alert, and so on, right? A lot of our customers work with a global user base, and that means the support tickets may not be always in one language. So we have been able to build similar solutions or replicate the same solution across the globe for handling different languages and so on. Now, there are some things that we did not show today, but as I mentioned, one of the clients that I talked about earlier was using an audio to text conversion utility from third party. With Rapidminer, we can again bring them in a solution like Rapidminer in a drag and drop approach. We have integrated with Google audio to text, but we can also work with any other third party provider that you like to work with. And also we have the ability to tag and highlight. So one of the additional steps we could do is not only, you know, classify the tickets, provide the topics and categories, but if needed, we can highlight and pinpoint to which keywords are important, what should be the engineers focus on. So that way, when they open that support ticket up, they will have their attention at the right item to look at right away. So with this, and hopefully the demonstration, you're able to see how Rapidminer can change your support team into an AI ML-driven organization. Uh, we are more than happy to take one-on-one demos and call requests as needed here. But in the meantime, I'm going to leave you with a couple of case studies. Those are available online. If you cannot note this link, you can also go to rapidminer.com/resources and you'll be able to search it over there. And additionally, if you have any questions, feel free to contact me here at bpatil@rapidminer.com, or you can leave us a note at http://rapidminer.com, US contact us, and somebody from our team will reach out to you. So thank you for your time, and hopefully we'll be able to help your support engineers become more efficient. Have a good day ahead.